Suppose you are given a problem like this. Simplify 45 over or raised to 100 divided by 45 raised to 98. So you might think that this is complicated. That's why we will be discussing the laws of exponents so we can discover simpler method on how we could answer this in just a sec. Okay, so let's first understand what these exponential numbers are. So when you are given, for example, 5 raised to 3, let's understand that the 5 here is considered as the base of the number, while 3 is the exponent. Now, the 5 being the base is actually the number being multiplied by itself depending on the number of exponents. So from this example, you have 3 as the exponent. That means that 5, which is the base, will be multiplied 3 times by itself. Now, do not be confused because sometimes instead of having 5 times 5 times 5, you are making it 5 times 3. That is a no-no. Again, when you have 5 raised to 3, that means 5 times 5 times 5, and the answer is equivalent to 125. Now, what are the laws of exponents? So the first law is the exponential form. When you are given x raised to n, remember that the n here is the number of times the x is multiplied by itself. Okay, so for example, the one that I just gave, 5 raised to 3, is actually 5 multiplied by itself, which simply means that if you are given, for example, x multiplied by x multiplied by a multiplied by a and another number or another variable which is also a, we can now have this as your x and x will be with each other because they are of the same base. So x will be x raised to the second power. So remember, if you cannot see any exponent, that is understood to be 1. So 1 plus 1 is equivalent to 2. And then we have a, okay, a with another a and then another a. That means a raised to the third power. Though this one, x squared, a cube, can be combined. And when we combine them, make sure that we are following the English alphabet, having a cube first. So a raised to the third power and then x raised to the second power. Okay? So that is your rule number 1. Now let's go to the other rule. We have here now the multiplying rules. So if you are multiplying exponential numbers with the same base, like in this case, x being the base, and then x also the other one, so x raised to m multiplied by x raised to n is equivalent to x raised to m plus n. Okay, so this just simply means that suppose you are given 3, for example, you have 3 raised to the second power, and you are multiplying this with another 3, but this time this is raised to the third power. So this simply means that you have 3 raised to the sum, okay, of 2 and 3, which is actually equivalent to 5. So 3 multiplied by itself 5 times. If you are going to do it in expansion, you have 3 raised to the second power as what the first rule says. So you have 3 multiplied by itself twice because that is the exponent. And then when you have another 3 raised to, or expression 3 raised to 3 here, this is actually 3 multiplied by itself 3 times. So 1, 2, and 3. So if you are going to count 3 or 3 multiplied 5 times, that is now equivalent to 3 raised to the 5th power. And if you want to find for the expansion, the answer that we are getting is 243. Okay? So that applies also when you are dealing with variables. Let's say, for instance, you are multiplying a squared and then b c raised to the third power. And we are multiplying this by a b squared and then c raised to the second power. Okay, or c squared. So remember, we can only combine those with the same base. So a will have to be with a. Okay, so if you are going to do this, a squared with a here. Now, remember, if you cannot see any exponent, that is understood to be 1. So a squared and the other a here will now result to a raised to the third power. And then b, again, we cannot see any exponent, so that's understood to be 1. And b raised to the second power, or b squared. So adding b, or 2 and 1, that's also 3. So b cube, or b raised to the third power. And then finally, you have c cube and c raised to the second power, or squared. Therefore, you will add now c, 3 plus the 2, that will give you 5. So this is now the simplified form of this problem. Again, if you are multiplying numbers with the same base, you just have to add the exponent. Okay, let's move on to the next rule, the dividing powers. So here we are dividing with the same base, but so based on the rule, what do we do? So we simply have to subtract the exponent. So if you have x raised to m all over x raised to n, that simply means x raised to m minus n. So if you are going to compare it with the question I posted a while ago, that we can apply here. So the question that I wrote there is 45 raised to 100, and that is over 45 raised to 98. So if you are going to use a calculator without your knowledge on the rules on exponent, maybe it will give you a math error. Okay, so what are we going to do here? We simply have to get, as we noticed, they have the same basis. So we have now 45, and again, we just have to subtract now 98 and 100. So the answer that we will be getting, 100 minus 98, is equivalent to positive 2. So we have now raised to the second power. Now, if you want to expand that, that will just be 45 multiplied by itself. Therefore, the answer that we will be getting is 45 times 45. That is equivalent to 2025. Okay, I will try to explain this rule with the use of a smaller number so I can easily expand. So suppose you have x raised to the fifth power, and then you are dividing this by x raised to the third power. So I will use a smaller exponent so that we can do the expansion. So when you have x raised to 5, this simply means that you actually are multiplying x 5 times by itself. That is your definition for the first one, right? So x times x times x times x. Okay? And then we have all over, we have x raised to the third power. That means x multiplied by x, and then another x. Okay, but we are aware, or we already have learned the cancellation process, right? When you have 3 over 3, a numerator and a denominator which are the same, you can just cancel, like 3 over 3, that will become 1 over 1. Okay, for variables, the same. When you have a over a, whatever the value, when you divide, that's actually one property that we have. So when you divide the same numbers, the answer is 1. That's basically the thing that we are doing here. So when you divide x by x, the answer is equivalent to 1 already. Okay, so we are able to cancel 1, 2, 3. So we have now three numbers or three x's being cancelled. So this is now only 1. And what is left here is just the x multiplied by x, which is actually equivalent to x raised to the second power. And that is the result of subtracting 5 and 3. So 5 minus 3 is equivalent to 2x raised to the second power. Okay? So in cases wherein you have x raised to the third power all over x raised to the fifth power, let's take note that the 5 or the new denominator has a higher exponent. So that simply means that in here, we will have 1 all over x raised to the second power. Now, applying the rule, which is actually the subtraction, this actually means that you have x raised to 2 or 3 minus 5, right? And obviously, the answer that you will be getting here in subtracting 3 minus 5 is equivalent to 2. So that is now x raised to negative 2. But remember, this is actually one of the rules. I will be discussing this later, that once you have a negative exponent, the simplified form, or if you want to take the positive form, you have to get the reciprocal. So we are back to 1 all over x raised to the second power. But anyway, I can explain it now. So when you have x raised to the second power, okay, this is the simple explanation for this. May I just erase this part? Okay, why the x raised to negative 2 is equal to 1 over x raised to the second power. So let's remember that once you have a negative exponent, so x raised to a negative 2 will become or is equal to 1 over x raised to the second power. Okay, so let's recall this one. If you have x raised to the negative 2, if I want to make this positive, okay, let's have that negative 2. If I choose to multiply this number by a certain number so that I will have x raised to the 0 power, I can multiply actually the x raised to 2 with x raised to, or the negative 2, x raised to negative 2 with x raised to 2. So if I will do that, I will not be changing the value because x raised to 2 over x raised to 2 is equal to 1 also. Okay? So if I will be doing this, this will result to x raised to negative 2 multiplied by x raised to the second power will simply be x raised to 0. Correct? Because when you have the same base, okay, we have the same base as here, we have x. We simply have to add the exponent. So as you notice, you have a negative 2 and a positive 2. So negative 2 plus positive 2 is equal to 0. And then 1 multiplied by x raised to the second power. So any number multiplied by 1 is the number itself. So still, you will have x raised to 2 here. But let's recall, what is a number raised to 0? So again, that's another rule on the laws of exponent. Any number raised to 0 is equal to 1. So therefore, this is equivalent to 1. So 1 over x raised to the second power. Now again, your question might be, why is any number or an x raised to 0 equivalent to 1? Okay, that's also a good question. Bakit, why are we having x raised to 0 is equivalent to 1? Okay, so if you have that question in mind, okay, let's have that. Okay, when you have x raised to 0 and I decide to multiply this by any number also with the same base x, or suppose I want to have x raised to 10. Okay, I want to multiply this by x raised to 10 over x raised to 10. Again, I am not changing the value because as you notice, when I simplify the x raised to 10 here with x raised to 10, it's equivalent to 1, correct? Okay, so if you are going to do this again with the same rule, x raised to 0 multiplied by x raised to 10, the rule states that you have to add the exponent, which means that if I will be adding the 0 and the 10, the answer is equivalent to 10. Okay, and then definitely this is understood to be over 1. So 1 multiplied by x raised to 10 is also giving me x raised to 10. So looking into this, what is x raised to 10 over x raised to 10? Again, the answer is equivalent to 1. Okay, so that explains why we have that rule also, that any number raised to a zero exponent is equivalent to 1. Okay, so our question is already answered. The 1 over x raised to the second power is the same as x raised to negative 2. And that when you have x raised to 0 or any number raised to 0, it's equivalent to 1. Okay? Let's have another rule. This is now the power of a power. So when you have x raised to m, quantity n or raised to a power of n. So what's the rule here? When it's a power of a power, we need to multiply. So x raised to m quantity n is equal to x raised to the product of mn. Now, let's have some examples. Suppose we have 3a and this a is raised to the second power and there is another exponent. Okay, we have now raised to the third power. So if you have this, it's just proper that we are going to distribute our exponent to each of the elements inside the uh, parentheses. So when you have 3a raised to the second power, this simply means that you have 3 raised to the third power, which means this is understood to have an exponent of 1. 1 times 3 is equivalent to 3. So that means you have 3 to the third power, and then a raised to the second power raised to 2 would mean that you have a raised to 2 times 3, which is now equivalent to 6. Okay, and if you are going to simplify this, 3 raised to 3 or 3 cubed is 27. So therefore, this becomes 27a raised to the 6th power. Now, why is this so? You have to remember when you say an exponent, it tells how many times a certain number is multiplied by itself, right? So when you have 3a squared raised to the third power, this simply means that you actually have 3a squared, okay, multiplied by 3a squared, and then multiplied again by 3a squared. Okay, so that is the simple explanation for this. So this is now the power of a power. That's the reason why you have now 3 times 3 times 3. This is basically now the 3 raised to 3 or the 3 cube, which results to 27. And then your a raised to the second power, and then again raised to the third power, that is a squared, and another a squared, which is now equal to a raised to 6. So again, our answer is 27a raised to 6. That is power of a power. Okay. Oh, and then we also have now the product law of exponent. So this is similar to the one I gave you a while ago, wherein you need to distribute. So in this case, you have xy raised to n. So again, if you have the product, this is now referring to the product of xy, which means that if you have 5 and then a raised to the second power, and then b raised to the third power, and then there you have another exponent, which is, let's say for instance, that is to the third power. So we need to distribute one by one. So the 5 there becomes 5 raised to 3. So 5 times 5 times 5, which results to 125. And then b, again, that is a power to a power. Therefore, 2 times 3 is equal to 6. So there should be a raised to the 6th power, and then b raised to 3, and then another exponent of 3. So that means b raised to 3 times 3 is 9. So that is how we simplify product law of exponents. Okay, and then we also have your quotient law of exponents. So when they are presented as in terms of a fraction, like x, y, quantity raised to the n power. So if this is the case, all you have to do is to distribute also. So for example, you have 3x and then all over 5y, and you have here raised to the second power. So it's just proper that when you do this, you have 3 multiplied by itself twice, so that becomes 3 squared. 3 squared is 9, x squared, we have it, x times x, so we have x squared. And then you have 5 squared, that would mean 25, and then you have y raised to the second power. So this simply means that you have 9x squared all over 25y squared. Okay, another example. Suppose you have here, let's say 21, and then x squared y raised to the third power, and then all over 14, and then you have x, y raised to the fourth power, and then we are trying to raise this to the third power. So if you are given problems like this, it will be wise to simplify first the terms inside the parentheses. Okay, so let's try to look for the simplified form. So like in this case, you have, obviously, you have 21 and 14, which are divisible by 7. So we can reduce that already and have it 7. And then dividing by 7, you have 3, while the 14 divided by 7 becomes 2. And then as you notice, you have x squared and then x. So using now your quotient rule, what are we going to do? Raise to the second power and then x. We can just cancel that. So that becomes now 1 here, and then the x here becomes already is already canceled. And then your y raised to the third power here becomes or is cancelled, and then you simply have y raised to the first power. So actually, the thing that we are now doing is simply 3 and then x all over 2 raised to, or 2y. Okay, and this is the number that we have to raise to the third power. Okay, and we have now 3 multiplied by itself 3 times. So we have 27, and you have x raised to the third power. While the 2 multiplied by itself 3 times by itself, that's 2 times 2 times 2. So that becomes 8. And then y raised to the third power. Okay, so again, we have the answer which is already in simplified form. Oh, this is the one that I just mentioned a while ago, the negative law of exponents. So once you have x raised to negative m, what we are getting is the reciprocal, 1 all over x raised to m. Okay, so that once you have 7x raised to the negative 2, what we are going to have now is, okay, you have to be careful on this. Again, the negative 2 is the only one which is raised to the second power. Therefore, the 7 remains as the numerator, while the x squared is the one that you have to reciprocate. So we have now 7 all over x raised to the second power. This is different when you have 7x, okay, and then you have this one as raised to the second power. This is the one wherein you are getting 1 all over 7x raised to the second power, or quantity squared, or the simplified form, which is equal to 1 over 49 x squared. Okay, so there is a difference when you put the grouping symbol here. That means that the 7 is included with the exponent of negative 2. Okay, and then we go to the last one, which is the zero law of exponent. So any number raised to a zero exponent is equivalent to 1. So this was explained a while ago already. So that any number raised to 0 is equivalent to 1. So again, I repeat. So for example, you have 5 raised to 0. This becomes equal to simply 1. Why? If you are going to explain that, you can just have 5 raised to 0. If I choose to multiply this by 5 raised to, let's say, 5, all over 5 raised to 5, if you will have the answer here, this simply means 5 raised to, we are adding the exponent when you have the same base. So 0 plus 5 is the same as 5. Okay, so when you have 5 raised to 5 over 5 raised to 5, again, by cancellation, the answer is equivalent to 1. So even if you have a very long number, let's say for instance 7x, y, and then you are adding that to 2x or 2z or any number, but this is raised to a 0 power, the answer is just 1. So those are the different laws of exponents.